also brought a contraption to draw circles. Let's hope it works. Okay. All right. So what do you do in this problem? You start off with the plane state of stress on the plane of loading. Okay. So what you would have done is you would have drawn the shear force bending moment diagrams. You would have drawn the state of stress on the area element, removed it out, drew the state of stress on the volume element, set up your view, crunched the three-dimensional cube to 2 dimensions. Then you would have ended up with the following state of stress, and that's what you're going to be seeing on Friday. Problems. Okay? X-axis, Y-axis. On these I have drawn according to the positive sign convention. Tau xy and tau xy, and then sigma xx, sigma yy. Okay. I'm going to call this side here as the side A. Okay, and then the opposite side as the side B. Then you set up an x and a y axis. Be careful, this is how Mohr defines it, so if you have questions you can ask him. Positive sigma on the positive horizontal side, right side, and then positive shear stress, look at this, on the negative y axis. By definition of how Otto Mohr came up with this technique. And why did he do this? Is because only if you do this will the answers that you get from this technique gel with the theory. Okay, otherwise it will be wrong. Then you draw what is called as the center of the circle. Center of the circle. The coordinates of the center of the circle will be the following. The center of the circle will be on the horizontal axis only, and the coordinates will be sigma xx plus sigma yy divided by 2. Divided by 2, this is the coordinate on the sigma direction, the coordinate in the tau direction is 0. All of you see that, right? There are 2 axes here. There's the sigma axis, there's the tau axis, which means if I'm specifying a coordinate on the plane, it should have 2 values. One on the sigma side, one on the tau side. The value on the tau side is 0, the value on the sigma side is based upon the state of loading, sigma xx plus yy by 2. So you go ahead and mark this on the circle. So probably somewhere here. Okay, call that point as a point C. This is negative sigma, and this is negative tau. Then, on the same plane, the sigma tau plane, you mark another point which is going to be called as point A, which is no coincidence, is going to be whatever is the state of stress on this side of the plane element. According to my sign convention, this is going to be sigma xx, right? That is the sigma value for the point A. And then I'm going to have tau xy, which is positive. If I'm writing the coordinates of point B, watch this. What's that going to be? It's going to be the opposite of this one. Okay, so that's going to be minus sigma xx. And then minus tau xy. Okay, so that will be the coordinates of the point B. Yes?
Did you establish a coordinate system or how to the population?
Okay, so this is for the Mohr circle. These values are written based upon the convention that we use for positive stresses. This stress is considered positive if it points along the positive x-axis on this face. On this face, it is not pointing along the positive x-axis, so it is considered to be negative. And likewise for tau xy, according to the sign convention, if I look at this particular face, if tau xy is pointing up, it is gelling in the direction of the area normal pointing along the positive x-axis, and so the shear stress, if it is positive, will be pointing along the positive y, and so that's why this guy is a positive value, which is written here. Okay, and this will be more clear when we start putting some numbers on the things. So hang on to that thought. I'm not really interested in the point B. All I need is point C and A, 2 points. I can draw the circle. Okay, so I'm going to mark the point A. Obviously, it's going to be somewhere in this plane. Does this make sense to everybody? Because of the fact that I have a positive sigma xx and a positive tau xy. Needs not be the case for all problems. Sometimes my sigma xx might be negative. Okay, but in this situation, this is probably where the point A is going to be. Then you can calculate the radius of the circle as the distance from point C to point A. This is the radius of the circle. Okay, so I'm going to write it somewhere here. So R. How do I calculate the radius if I know the coordinates of 2 points? Square root of the sum of the squares, the Euclidean norm. Okay, I'm going to get rid of this panel here. And just as a point of reference, most people who do mechanics are mathematicians, because it is the most useful field for mathematics to show itself in terms of utility to engineering values. And it is unfortunate that we are getting to the real stuff in mechanics towards the end of the semester. You know, we were just getting used to writing out equations, solving problems, but this is the heart of the matter. It's the heart of darkness here. Okay? So the radius are square root, distance from point C to point A. Okay, so this is distance from C to A. Let me write it somewhere here. Distance from C to A, so that's going to be sigma xx plus sigma yy by 2 is typically called the average. So the coordinates of C are sigma average and 0, and so this is going to be sigma average, sigma xx squared, the sum of the difference between the x coordinates and square, plus 0 minus tau xy squared. This is the radius of the circle. Once I have the radius and I have 2 points in a circle, I can obviously draw the circle. So I'm going to draw the circle. Okay? Let's hope it works. Okay, more or less a circle. So this is the circle. Now, this circle has 4 points of intersection which are of importance to us. The first point, second point. Then if I draw a vertical line passing through the center C, third point, fourth point. Okay? So these are my points of interest. The distance from the origin, which is the point O, so O is the origin. Okay, distance from the point O to the end point here, which let me call as point, I guess C, I have D, E, F, and G. Distance from point O to point D is the first principal stress value. So if I draw the circle, I have everything. This is equal to sigma 1. Distance from point E to point O is the second principal stress value, and you can see that that can actually be a negative value. Okay? This is sigma 2. Distance from point O to point F is the maximum in-plane shear stress value but negative, and on the other side it's the maximum in-plane shear stress value, which is a positive. So if you draw Mohr's circle, you're good to go. You have pretty much everything, including the angles, which I'm going to talk about in a second. So this height here is minus tau max in plane, okay, from the origin all the way to the point F, and likewise to the point G, plus tau max in plane. This line AC is called the reference line. Okay. So AC, CA, reference line. So whenever you draw the Mohr circle, the things that you need: origin, easy, 0, 0. The center of the circle, if I know the state of stress, the center of the circle is easy. I need the coordinates of point A, which is going to be, in this case, whatever is the state of stress on the right side of this element. I can calculate the radius, which is the distance from point C to point A, and I can find out all the important stress states here. And lastly, counterclockwise, from the line AC all the way to where the first principal stress resides is going to be 2 times the principal stress angle theta P1. And I'll tell you why it is 2 times in the next lecture when we solve problems. For the time being, just take it as a matter of fact. This is 2 theta P1. Always go counterclockwise. Every time we've done anything, the rotations have been positive counterclockwise. So I will always go counterclockwise only. Everywhere I go counterclockwise. Okay? And then, all the way from the reference line, counterclockwise to the first shear stress that you hit, which in this case is the point F. This angle is going to be 2 theta S1. And if you want 2 theta P1, it's going to be all the way from here on to that. And if you want 2 theta S2, you go all the way from this line to theta S2. Remember, counterclockwise. Don't go clockwise. If you go clockwise, you have to draw the rotation. You can go clockwise, but you have to draw the orientation properly. So it is wiser to go counterclockwise when we follow all the sign conventions. Your TAs will solve 2 problems where they will give you this state of stress. Bear with me for one last minute. Your TAs will solve 2 problems where they will give you the state of stress. They will find out, okay, what is the origin, what is the center, what is the point A, what is the radius. Draw the circle. Then after you draw the circle, you will figure out the numerical value for sigma 1, numerical value for sigma 2. Depending on the problem, it could be positive or negative or 0. You don't know. Numerical value for tau max, and then all the angles.